Good morning friends and dear students. Today we will going to discuss about the IC, that stands for the integrated circuits, and today we will going to discuss about the NOR gate. So you can see that we have already discussed about the OR gate, AND gate, NOT gate, and today we will going to verify the truth table of a NOR gate with the help of a IC. So you can see that the IC number of NOR gate is 7402, and if I show you, you can easily see it here. It is mentioned here, so you can see that it is CD74HC02E. okay, so you just have to remember that 7402. okay, this is the NOR gate IC. So each manufacturer has got different configuration of a nomenclature of writing this IC. So we will going to use this NOR gate IC. So we will going to perform this NOR gate IC with the help of a experiment. To perform this experiment, first we will going to understand about the symbolic representation of a NOR gate. So you can see that we have got A here and we have got B here. So we are providing the input A and B here, and this is the symbolic representation of a NOR gate, that is NOT with OR. So this is NOT gate. That means in OR you were getting the output A plus B, but what we are getting, we are inverting the output of a OR gate. So therefore it is known as the NOR gate. And if I go to the truth table of the OR gate, so you can see that when we are having an input at 0 0, my output is 1. Rest, whenever the input we are getting 0 1, 1 0, 1 1, our output is 0. What it means, that let me consider an LED, that stands for the light emitting diode. So what I can say, that when I am connecting my input at a 0, that is positive logic 0, my output of the LED will be on. That means my LED will going to be on. Whereas when my input is 0 and my input B is connected to the 5 volt, my output will be 0. That means my LED will be off. When my input 1 is at positive logic and my input B is negative logic, that means it is at ground, my LED will be off. Similarly, when both my input A and B are at positive logic, my LED will be going to be off. So you can easily see that it is the operation which is performed with the help of a NOR is the inverted operation of the OR gate. So at the OR gate we were getting 0 at 0 0 and rest we are getting the 1, but here at the NOR gate we are getting the reverse operation. That means at 0 0 we are getting the 1 and rest we are getting the 0. Now we will going to see the IC packaging of this. So you can see this IC packaging of this. So the 7402 is the NOR gate IC. So you will be using this NOR gate IC. Now you can see that at pin number 1 we are getting the output and we are providing the input at pin number 2 and 3. Similarly, at pin number 4 we are getting the output, and at pin number 5 and 6 we are providing the input. 7 we are keeping it as a ground. Similarly, 8 and 9 are being used as the input, and at pin number 10 we are getting the output. Pin number 11 and 12 we are providing the input, and at pin number 13 we are getting the output, and pin number 14 we are providing a positive supply, that is plus VCC. So this is the IC package of 7402. So this is the internal structure. So if I show you the IC again, so you can see that again we have got this notch 1 2 3 4 5 6 7, and then here 8 9 10 11 12 13 14. Okay, so if I keep it here, you can see at pin number 1 I will be getting the output, that is Q1, and pin number 2 and 3 we will be providing the input, that is A1 and B1. Similarly, at pin number 4 we will going to get the output, and at pin number 5 and 6 we will going to provide the input. Pin number 7 we have to connect it to the ground, and pin number 14 we have to connect to the VCC. So we will going to see this thing with the help of an experiment. So now we have got this breadboard, and then what we will going to do, we will going to insert this IC in this bread. So we have inserted this IC. So see, first what we will going to do, we will going to connect the pin number 7 to the ground. So we will going to take a pin number 7 and we will going to connect it to the ground. Let's say we are taking this part of a breadboard as a ground, and at pin number 14 we will going to connect it to the VCC. So let me take this one as the now what I will going to do, I will going to take a blue wire and a yellow wire as a 2 input. So where I have to apply the input, you can see at pin number 2 and 3 we have to apply the input. What I have to do, I have to just to verify my truth table, I will be taking the output from the pin number 1. So I will be connecting the LED at pin number 1. So what I will going to do, I will directly connect the LED at the pin number 1. Okay. Now you can see that we will going to take a battery. So you can see this is our battery, a 9-volt battery. So this is a positive terminal, that is the red wire which is coming is a positive part of a battery, and the black wire which is coming is a negative part of a battery. So we will going to connect a negative part as a ground. So we are connecting it here, and we will going to connect a positive part of our battery here. Okay. Now we will going to verify our truth table. Okay. So let me connect. I'm just taking this part. Okay. So let me just make a connection again. So I will be taking the output from a pin number 4. So if I going to count 1, 2, 3, 4. So I will be connecting my LED here. 1, 2, 3, 4. So let me connect my LED here. Okay. Now you can see my LED is on. Now what I will going to take, I will going to connect input at pin number 5, that is this 5, and pin number 6. Okay. And what I will going to do is that first I will going to connect it to the, let's say I will going to take my truth table and will going to verify it. So 1 is 0 0, that means my input A and my input B should be 0 0. 0 0 means that it should be connected to the ground, means this and this. Now you can see that when I have connected it to the ground, that means my A input, that is yellow wire, I have taken as a A. So I am writing here this is my yellow and this is my blue wire. So you can see that when yellow wire and blue wire are being connected to the ground, I am getting my output as a 1. Now what I will going to do, I will take my yellow as a 0 only and blue as a 1. So I will remove the 1 and will going to connect it to here. Now you can see that at 0 1 my LED is off. Okay. So you can see the LED is off. Now I will going to take back and I will going to connect it here. Now again you can see I am at this position 0 0 and my LED is on. Now what I will going to do, I will take yellow at a 1 and keep the blue at 0. So you can see that at this time also my LED is off. Now what I will going to take, I will connect all yellow and blue to the positive logic and you will going to see that my LED is off. So in this way we have verified our NOR gate truth table, and you can see that we have performed this experiment using the IC 7402. So thank you for watching this video.